Hi, everybody. This is Dr. Nigro with the Chemistry Notes screencast. The screencast is going to be the last in my series dealing with Unit 3. Our focus in Unit 3 was multi-pronged. We did some naming, we did empirical molecular formulas, some balancing, and then we are ending with stoichiometry. All right. I have two earlier stoichiometry screencasts. That the first one that deals with what stoichiometry is and what the mole ratio step is, and then does some simple one-step stoichiometry problems. The second looks at a little bit more complicated problem in that you start with mass or end with mass. So it's a two-step stoichiometry problem. So if you have questions about either of those types of problems, please go review those screencasts. All right. And don't forget, you have to be able to balance reactions. So if that's giving you trouble, you definitely want to go review that information as well. All right. These stoichiometry problems are going to be as complicated as it can get when it comes to stoichiometry, in that you're going to start with the mass of a substance and need to convert that over to the mass of a different substance within a chemical reaction. All right, so these are going to be three-step, whoops, stoich problems. Now, later, we are going to learn some other ways to represent amounts of substances besides the gram, uh, but we'll just add that on. You'll see what I mean. We'll talk about it a little bit at the very end of the screencast. All right, so the plan's going to look a little bit different for this type of problem compared to the others. It's going to have 3 steps versus 2. All right, so what does that mean? Well, let's say we've got grams of A and we are asked to convert that into grams of B, where A and B are both parts of a chemical reaction. All right. So because A and B are different chemical entities, there's no conversion factor that links the two directly. So you cannot do this conversion directly. All right. So hopefully with the last screencast, you learned that whenever you're not in the mole for a stoichiometry problem, your goal should be to get to the mole, because that's where you can make the jump. All right, so my first step is going to be to take the grams of A and convert that into moles of A. And I do that by using the molar mass of that substance using the periodic table. All right, now moles of A to grams of B, that's still not going to work, right? Because I still have two different chemical entities. All right, so I'm not quite there yet. So I'm going to have to convert that moles of A to something else. And that's going to be moles of B. All right, so to make that jump between chemical entities, you have to be in the mole. And we use the mole ratio to move between the two substances using the coefficients from the balanced chemical reaction. All right, now once I'm at moles of B, I can go to grams of B. That is a step I can do using the molar mass again, but this time of B. So you can see there's going to be 1, 2, 3 steps. So 3 conversion factors. And I know that that sounds complicated, but we're just going to follow the same pattern that we've been using for all of our mole conversions and now our stoichiometry problems. The unit that you're trying to get rid of goes in the bottom of your conversion factor. The unit you're moving towards goes in the top. And then in your second conversion factor, what's in the top of the first conversion factor goes in the bottom. And then where you're going goes in the top. And then you just keep following that pattern down your unit conversion problem. All right. So if you're systematic about how you do these problems, they become a little repetitive and you kind of get the hang of it, but you have to practice. You can't just hope for the best the day of the test, right? We got to practice. Okay. All right. So we're going to go through a couple problems together. We're going to first have to write a reaction. So we have aqueous silver sulfate, Ag2SO4, which reacts with aqueous iron 3 chloride, FeCl3, to produce solid silver chloride, AgCl, and aqueous iron 3 sulfate, Fe2SO4 3. All right, so write the balanced chemical equation. All right, so we'll start with our reactants, Ag2SO4, and it tells us it's aqueous. All right, and that's going to react with iron 3 chloride, which is also aqueous. All right, it's going to produce silver chloride, and it tells us that the silver chloride is a solid. And then we've got iron 3 sulfate, which is also aqueous. All right, now for balancing, Here we have a polyatomic sulfate that shows up on the opposite sides, products and reactants, as sulfate. So the polyatomic ion is seen on both sides. So we're not going to split that guy up into sulfurs and oxygens. We're just going to balance it just like we would any other substance. All right. So I have 3 sulfates on the product side, but only 1 on the reactant side. So I'm going to start by putting a coefficient of 3 in front of my Ag2CSO4, Ag, Ag2SO4. All right. Now that's going to give me 6 silvers. So I need to balance that over on the product side. So I'm going to put a 6 in front of AgCl. All right. Well, that gives me 6 chlorines on the product side, but I only have 3 on the reactant side. So I'm going to put a 2 in front of FeCl3, which gives me 2 irons, which I have over on the product side. So now I'm nice and balanced. All right. So as I have done on the other videos, I am going to copy this and then I'm going to paste it down here because I like to write underneath it. But as you know, that is way too big. So I'm going to shrink it down so it's easier to work with. And I'll just be using that with each reaction or each problem as we go. All right, so let's read our first one. All right, so we have 311.18 grams of silver sulfate that reacts. We're asked how many grams of silver chloride will be produced. All right, so we've got 311.18 grams of silver sulfate, and we're asked to find grams of silver chloride. All right, so 311.18 grams, and we're asked to find grams of silver chloride. All right, so you can see that we are moving between chemical substances within the reaction, which should tell you stoichiometry, which means we need a mole ratio step to move between the 2 entities. All right. So for our plan, 311.18 grams of Ag2SO4, and we're converting that into grams of grams of AgCl. All right, so as we mentioned before, because these substances are different, we can't go directly. So our first job is going to be to convert those grams of silver sulfate into moles. So we're going to need the molar mass of this substance to make that jump. All right, once we have moles, we're going to convert those into moles of silver chloride. All right, so here's our mole ratio step, which we knew had to be there because of the stoichiometry aspect. And then we're going to go to grams of AgCl using the molar mass of that substance. All right, so as soon as I see that I'm going to need all these molar masses, all right, I just pause and calculate the molar mass. All right, so I'm actually going to write them up above just so I can remember them for later in the problem. All right, so Ag2SO4, that's 2 silvers, a sulfur, and 4 oxygens. If I use my periodic table and plug it all in, I find that that's 311.81 grams per mole. All right, I'm going to repeat that, but I'll look at FeCl3, so 1 iron and 3 chlorines. I use the periodic table, and it's 162.20 grams per mole. All right, and since I'm doing it for the reactants, I might as well do it for the products. All right, so I've got AgCl, which is 1 silver, 1 chlorine. I add those up, 143.32 grams per mole. And then the big one, this is a big molecule, Fe2SO4 3, or formula unit, I guess would be a better way to say it. All right, this has a mass of 399.91 grams per mole. That's a lot. That's a lot of mass. All right, so I'm going to just be referring back to those throughout these problems. All right, now you won't need to do that every time. This is a problem set that everything uses the same reaction, so it's useful to have it all done. You may just be doing one-off, so you may not need to do that. All right, so I'm going to start way over here, 311.18 grams, and I'm going to cheat as well, silver sulfate. All right, so I don't have to write the formulas. All right, if you would like to do that, that's fine. You just need to tell me what your abbreviations mean in terms of the formulas. All right, so I'm going to put grams of silver sulfate in the bottom, and I'm going to moles of silver sulfate up top, and that's a molar mass step. And I calculated that 1 mole of silver sulfate has a mass of 300, oh, look at that, and 11.81 grams. They're almost the same. All right, that's going to let me cancel these grams. All right, but I'm not done. The problem asks for grams of AgCl, and I'm not there yet. I'm only at moles of silver sulfate. All right, so for my next step, I'm going to put moles of silver sulfate in the bottom, and my plan tells me I'm going to moles of silver chloride, so AgCl. So I'm going to need to go check my balanced reaction, and it tells me that for every 3 moles of silver sulfate, I'm going to produce 6 moles of silver chloride. All right, so that's going to let me cancel the moles of silver sulfate, but I'm still not done. All right, because again, it doesn't ask for moles of silver chloride, it wants grams. All right, so the moles of AgCl will go on the bottom this time, and grams of AgCl will go up top. And this is a molar mass step, and I calculated that 1 mole of AgCl has a molar mass of 143.32 grams. All right, so that'll let me cancel my moles of silver chloride, and I'm left with grams of AgCl. All right, so now it's just the calculator. So 311.18 times 6 times 143.32 divided by 311.81 and then divided by 3. All right, so I got 286 grams of AgCl will be produced when I start with 311.18 grams of silver sulfate. All right, so you can see it's the same pattern of problem solving that we have been doing. We are canceling units. So we need to put the unit that we're trying to cancel in the bottom of our conversion factor and the one we're trying to reach in the top. All right, so let's try another one. We'll put our equation down here again. If 0.236 grams of AgCl is produced, how many grams of FeCl3 must have reacted? All right, so this is our given amount, and this is what we are trying to find. All right, so we have 0.236 grams, and we're asked to find grams of FeCl3. So as soon as I see that I have amounts for 2 different chemical entities, stoichiometry. So I'm going to need a mole ratio step. But first, I got to write out my plan. So 0.236 grams of AgCl, and we're trying to convert that into grams of FeCl3. All right, so because these are 2 different chemical entities, there's no direct jump. All right, so I'm going to need to convert first from grams to moles for that silver chloride, and I'm going to need the molar mass of silver chloride to make that happen. Once I have moles, now I can convert over to moles of FeCl3. I can't go to grams, but I can go to moles, and I can do that with the mole ratio. And then once I have moles, I can convert to grams using the molar mass of FeCl3. So again, it's going to be a 3-step problem, just like we saw before. All right, so we start with what we've been given, 0.236 grams of AgCl. My first conversion factor is going to have grams of AgCl in the bottom and moles of AgCl up top. That's going to let me cancel those grams. And according to the periodic table, a mole of AgCl has a mass of 143.32 grams. So I'm going to cancel the grams, but I'm not done. I need to work my way over to FeCl3, and this is where it's going to happen. All right, my mole ratio step. So 1 mole of AgCl versus the moles of FeCl3. All right, and according to the balanced chemical equation, for every 6 moles of AgCl produced, I needed 2 moles of FeCl3 to react. All right, so that's going to let me cancel my moles of AgCl, but I'm still not done. All right, one last step. I need to convert from moles to grams. So moles of FeCl3 will be in the bottom. Grams of FeCl3 will be up top. And this is another molar mass step. And 1 mole of FeCl3 has a mass of 162.20 grams. So that's going to let me cancel the moles of FeCl3, and now I am left with grams of FeCl3. So all my units canceled except the last one, which is what I'm trying to get to. All right, so now I just need to plug it into my calculator. So 0.236 times 2 times 162.2, and then I'm going to divide that by 143.32, and then divide that by 6. And I get 0.0890 technically grams of FeCl3. All right, which is reasonable, right? Because that's not very much AgCl that was produced, so it's reasonable that I didn't have very much of the reactant reacting. All right. All right. Let's do the next one. All right. Again, let me get my reaction down here. Okay. If you form 23.6 grams of Fe2SO43, how many grams of AgCl are also produced? All right. So we're given grams of iron 3 sulfate and asked for grams of AgCl. All right. So we have 23.6 grams of this, and we're asked to find grams of AgCl. So again, two different chemical entities, stoichiometry problem. Gonna have to have a mole ratio step somewhere in my calculation. All right, so let's set up our plan. So 23.6 grams. Oh goodness, I'm just gonna say iron sulfate because that's a lot to write. All right, don't tell my chemistry teachers I said that. All right, grams of AgCl. All right, again, because we have two different chemical entities, all right, that we cannot move directly between these two substances. So we're going to have to do some converting to work our way over. All right, our first job will be convert those grams of iron 3 sulfate to moles of iron 3 sulfate, and we'll do that with the molar mass of the substance. All right. We're then going to convert to moles of AgCl because the mole is where we can make that jump from one substance to another. And we do that with the mole ratio step. All right. Once we have moles of AgCl, then we can go to grams, but we'll need the molar mass of AgCl to make that happen. So again, three-step conversion, just like what we saw before. All right. We set it up. 23.6 grams of iron sulfate. All right, for my conversion factor, the gram of iron sulfate is going to go in the bottom. Moles of iron sulfate is going to go up top. And using the periodic table, I know that 1 mole of iron sulfate has a lot of mass, 399.91 grams. So this is going to let me cancel those grams, and I'm at the mole. All right, but according to my plan, I still have a ways to go, right? I need to now convert from moles of iron sulfate over to moles of silver chloride. All right, I use the mole ratio step for this, which means the balanced reaction coefficient. So I look, all right, for every 1 mole of iron sulfate that's produced, I'm going to produce 6 moles of silver chloride. All right, so I'm going to cancel out the moles of iron sulfate. All right, but I'm not quite done. One more. All right, I need to convert moles of silver chloride to grams of silver chloride using its molar mass. And I know that 1 mole of silver chloride has a mass of 143.32 grams, as I calculated with the periodic table. All right, so that's going to let me cancel the moles of silver chloride. Everything's canceled out except grams of silver chloride, which is what the problem asked me to find. All right, so I have 23.6 times 6 times 143.32. All right, then I'm going to divide that by 399.91. And I'm going to get 50.7 grams of AgCl are produced when 23.6 grams of iron 3 sulfate are produced. All right. All right, last one. Okay, if you have 100.5 grams of iron 3 chloride to react, how many grams of silver sulfate do you need? All right, so we've got 100.5 grams of iron chloride, and they're asking us how many grams of silver sulfate we need. So here's what we've got. All right, here's where we're going. Oops, I meant to underline that. Sorry about that. Okay. All right, so we're definitely moving between chemical entities. So it's a stoichiometry problem, and we're going to need a mole ratio step. All right, so I'm going to start with my plan 100.5 grams of FeCl3, and I need to convert that into grams of Ag2SO4. All right, so as we've seen with all the other problems, we have two different chemical entities here, so we cannot do a direct conversion. All right, our first step is going to be to go to moles of FeCl3, and we do that with the molar mass of that substance. All right, but we're still not quite there. We need to convert that into moles of Ag2SO4, and there's our mole ratio step. All right, and once we convert it over to this other substance, then I can go to grams using the molar mass of silver sulfate. All right, so again, it's going to be a three-step problem. We're going to set it up just like we've done all the other ones. We're going to start with the number that we've been given, 100.5 grams of FeCl3, and our first step is to convert those grams into moles. So the gram's going to go on the bottom, and the moles of FeCl3 will go up top. All right, we're going to use our periodic table, and we're going to find that 1 mole of iron 3 chloride has a mass of 162.20 grams. So that's going to let me cancel my grams. All right, but I'm not done. According to my plan, I now need to convert over to moles of silver sulfate. So I'm going to put moles of FeCl3 on the bottom of my conversion factor and moles of Ag2SO4 in the top. All right, now I need to go look at my balanced reaction, and it tells me that for every 2 moles of iron 3 chloride that reacts, I'm also going to react 3 moles of silver sulfate. All right, that's going to let me cancel the moles of iron 3 chloride, and then I'm going to wrap it up by doing a molar mass step. All right, so moles of Ag2SO4 on the bottom, grams of I'm running out of room, SO4 on the top, and 1 mole of silver sulfate has a molar mass of 311.81 grams. So that's going to let me cancel the moles of silver sulfate, and I'm going to be left with 1 unit, which is grams of silver sulfate. All right, so now it's just the calculator. 100.5 times 3 times 311.81. Then we divide that by 162.2 and then divide again by 2. And I have 290 grams of Ag2SO4 are needed to react with 100.5 grams of iron 3 chloride. All right, so you can see how handy stoichiometry can be. If I have a certain amount of reactant, I can use stoichiometry to calculate how much of the other reactant I need. If I know I need to make a certain amount of product, then I can use stoichiometry to figure out how much of each reactant that I need to make that particular amount of product. All right, if I know how much of one product I made, I should be able to calculate how much of the other product was made simultaneously. So you can see how a scientists might want to be able to do these types of calculations. All right. So being able to do a 1-step, 2-step, or 3-step stoichiometry problem is going to be a very important skill that we are going to be working on over the next several units. All right. Now, I want to do a brief pause to talk about the Stoich map. All right. This is something that I tend to draw on the board while we're working in these units, particularly as we start to add on to the map. All right. So we're just going to do a very general reaction. A goes to B. All right. But this could be any reaction we've already talked about. At the center of your stoichiometry map is the mole ratio step. So moles of A, whoops, I didn't mean to do that. Oh, let me start over. Moles of A converting to moles of B. All right, that is your simplest step, your 1-step problem where you use a mole ratio to do that conversion. All right, now the more complicated problems, maybe instead of moles, you start with grams of A. All right, and if that's the case, you need to convert first to moles of A using the molar mass of that substance. Then you can go to moles of B. All right. Or maybe the problem gives you grams of A and asks for grams of B. So you need to go grams to moles using the molar mass, moles to moles using the molar ratio, and then moles of B to grams of B using the molar mass of B. All right. Now, obviously, for all of these, we could go in the other direction, right? We could have grams of B and work our way around to grams of A. So you can go in either direction. All right. Now, you notice I did not draw this in a straight line. It's because grams are not the only thing that we can convert to moles with, right? Maybe instead you've got particles of A. All right, and we want to get to B. So if that's the case, we're still going to need to do a conversion factor, right? We need to take particles of A to moles of A, and we need Avogadro's number to make that happen. And we can go to moles of A and then do a mole ratio step to moles of B, and then we could go to grams of B if we wanted. Or maybe the problem then asks us to convert to, sorry, particles of B. All right, and again, we would need Avogadro's number to make that happen. And then as we saw with grams, we could also go in the other direction. All right. We could also mix and match. Maybe we have grams of A and we're asked for particles of B. All right. Maybe we have grams of B and we're asked for particles of A. All right. So, one thing I always tell my students when it comes to stoichiometry, you have to become flexible. All right. Your entrance into the mole ratio step and your exit from the mole ratio step, you're going to have a variety of options. And as we continue through the year, we're going to add to this map. All right. The key is this step in the middle is always there. All right. It doesn't matter how you get to moles of A, you have to get there before you can move over to moles of B. There has to be a mole ratio step, and it's usually in the middle of these problems. All right. So for now, I don't want you to be surprised if particles pop back up every now and then. We tend to stick with mass. All right, but particles are a possibility. It is something that we know how to do. All right. All right. So if you have any questions about stoichiometry or how to work these three-step problems, please let me know. And we're going to keep practicing and we're going to become experts. I promise.